Hello and welcome back to Mask Miller Learning and Mask TV. Grade 10, we are here with you again today and we have promised you to do probability. Please stay with us and we'll see how we're going to maneuver between the grade 10 probability, which is usually your paper 1 and the examination or any task you do. Right, during this session, you need to be able to deal with the theoretical and also experimental probability, and that then has a specific formula that we use, that is a probability of a particular event, which is equals to the favorable outcome divided by the total outcomes. So with that, we're going to show you how we're going to use the formula to get to the solutions. Also, you need to be able to draw the Venn diagram, or else you also have to be able to interpret the Venn diagram if it's given to you using the formula that we call additional rule formula. That is the probability of A union B, and at some point in some books you will see that it said the probability of A or B. So this same representation of the probability of A union B, right? Please pay attention to that. That is equal to the probability of A plus the probability of B. Again, minus the probability of A, and it has something that looks like an N, but this is actually called intersection. So that means that both A and B can occur at the same time, and another way of representing that is the probability of A and B. Right, so please just pay attention and take a note for that. With that, we can also learn how to deal with mutual exclusive events where we know that the probability of A intersection B, or the probability of A and B, will always be equal to 0. This is when there's no intersection between the two events, right? Also, you need to understand or be able to understand the complementary events. So complementary events just simple means that the event will have the sum of 1 all the time. So with complementary event, the probability of one event, which we can call it A, plus the probability of the other event, which we can call it B, must always be equals to 1. And another way to embrace the complementary event is to say that the probability of what it is not, the event that is given, is equals to 1 minus the probability of what it is given in the event. We can write it as the probability of not A equals to 1 minus the probability of A. Another way of writing it, we can say the probability of A with that slash just at the top that also represent not A will then be equals to 1 minus the probability of A. Please pay attention to this, because remember, we don't get the formula sheet in grade 10 where you would know which formula to use when. What guides you will be the information such as the one that talks about addition rule. That is one of the example. If you see addition rule, you need just to remember that this is what you need to do. If you have a Venn diagram, also you just have to remember that this is the formula to go to. But you always have to pay attention to what is given, right? So if they give you information that can allow you to use that, then you go with that. Again, when you talk about mutual exclusive, just always remember that there is no intersection, meaning that the probability of A intersection B, which is and B, is always equals to 0. So this is what you just formulate when you talk about it. Every time you hear complementary, remember that the probability must add up to 1. Now, we can then move away from that and just show you few examples that will help us understand this language. Because believe it or not, with probability and its language, many of us don't understand it because there's too much language in it that you need to know and understand. So please stay with me as I go through the examples. Okay. So this is where we use the addition rule. So with addition rule, as I have just indicated, so suppose you are given a Venn diagram like this, and you are told that this is A, or that is the event where A is occurring, what is we have labeled as 1, and then the other one is B. So for you to know what will be the probability of A, or what is the numbers of the probability of A, you just have to look and focus on what is A only. Do you see how I'm highlighting it there? You look and focus on what is A only, as well as if you were given or you have to find the one for B, you also just look and focus on what it is only B. One will be asking, why am I just circling them away from this point where we have the highlighted part here? Why am I not adding this? It's simple because this is the point of intersection that we are talking about. So this will be the probability of whereby they intersect, which is this part. Whereas this red one, which I've highlighted on the left, is the probability of A. And then the one that is in green is the probability of B. So that is what you look at. Just always remember that, and that happens with each and every event that you can go through. Okay. Now we have mutual exclusive. So with mutual exclusive, I am going to show you how we're going to actually determine that these two cannot happen at the same time. In reality, what I use as an example of mutual exclusive is an ID number. I mean, an ID number belongs to one person. There's no way that myself, my sister, my brother, my child will have the same ID number. So ID number belongs to one person. These 5 people cannot have the same ID number, right? So that is mutual exclusive. It cannot happen at the same time. Or we can literally just call it an event that is never going to happen. So let's read the statement together. Remember, in maths, when you analyze the statement, you always, and this is very, very important, you always must just point out the information that is important. If need be, label it and say, I have this, I don't have this. You will go far in that way. Okay, so let's see. Here, they said event A and B are said to be a mutual exclusive, right? And they said if they cannot, you see that is coming up, if they cannot occur at the same time, therefore mutual exclusive event cannot have anything in common. That's what we have just said. They cannot have anything in common. So then that means that that mutual exclusive as well, we can call it disjoint event, right? So if we look at the information that is given here, we can see that our sample space, total sample space, is these numbers that are written there with 1, 2, 3, 4, 5 up until 10. So if I have to then draw my own way of finding if these are mutual or they are not mutual, I'll simply just have to have, let's draw it in this side so that we can able to see what is coming up there. Just gonna draw my sample space like that. Okay, so we have the sample space, and then now I'm going to draw my Venn diagram, right? Remember, this Venn we are talking about is not a car. It's just a description of this diagram. Is called Venn diagram. So please do not look for a car when we say Venn diagram. These are the Venn diagram we are talking about. The name of this diagram is called Venn diagram. So there's no car that will come in a Venn format. Okay, please take note of that as well, because many people that I've taught have went to that road where they say they want to see the Venn. We don't have a Venn. This is the Venn diagram. Okay. Now, if I have to put my event A, or for A, you can see that I'm having 1, I have 3, I have 4, I have 5, I have 6. These numbers are not repeating on the event of B. So that means on B as well, I'm just going to write it as 8, 9, and 10. That's what I have. There's nothing that is happening at the same time. If ever one was appearing on the both of them, I would not write it on any side, but I'll write it on the intersection. At this time, it shows that there's nothing on the intersection point. So I'm going to leave it like that. But if you check the information that we have, we're given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you look at it properly, you can see that we have missing something. So what is missing there is that we do not have 2 and we do not have 7. So because 7 and 2 are not in there, we're literally going to just write it outside. So I can come and put my 7 and the 2 outside. So this is me trying to represent what is given there. But in a nutshell, when you are drawing for the probability, you'll be saying, how many numbers do I have here for me to get the probability? Remember, we are having total of 10. So it means I will have 1, 2, 3, 4, 5. And that is why you will see on our other side, it is written as 5. This 5 represent the probability of that particular one. As well as on the other side, you see, we have 3. This 3 just represent that I have 1, 2, 3 numbers inside here. As well as outside, I have 2. This 2 is not the same 2 as the one that we have put here. It's just the counting that I have 1, 2 numbers. Please just pay attention to that. So this literally just told me that I do not have the probability that has an intersection. But I do have my probability of A, which is going to be equal to 5 divided by 10, right? So this is my focus, which is A. It is what we have said is favorable. And then the 10 is the total outcomes, which is the numbers that are given into our space. So you can simplify this one further to get a half. So that is my probability of A, right? Same will happen if I have to write the probability of B. The probability of B will be equals to 1, 2, 3, as we said. That will be 3 divided by 10. That will be my probability. Do we have the probability of the intersection? No, we don't. So there's no probability of the intersection. So we don't have the probability of A and which is the intersection of B. We do not have, please bear in mind that this and is not an N. You have to try and make sure that you write it without N on it or without showing N. So it is not N, you write it like that. This whole probability is equals to 0, as it is evident on our diagram that we don't have that. Therefore, this is mutual exclusive. Okay. Then we have the complementary, which we have done as well. So with the complementary one, we said if we're looking for the complementary, the probability of what we don't have or what it is not. So that will be the probability of A with a dash. So here the example says, find the probability of not rolling a 6 on a die. So you are rolling a die, but you are not getting 6. So what is the probability? Remember, the die have 6 opportunities because it has 1, 2, 3, 4, 5, 6 sides. So those opportunities or those probabilities that can happen is therefore going to be 6 of our total. But how many times do you anticipate of getting 6 as you roll a die for it to happen at once? Only one time. So that means in the normal space, my probability of getting a 6 will therefore be equals to 1 over 6. Where the 6 here represent the full set of a die. But if I am looking for the probability of not a 6, which is 6 but not, remember this means not a 6, then that will be equals to 1 minus 1 divided by 6, which give us 5 divided by 6. Right? So please take note and pay attention to that. Here, there's an example that I have taken from our Platinum Books Math, which is on page 295. There you can get many, many examples. A very exciting one about how to deal with Venn diagram and how to calculate questions related to Venn diagram. So I'm going to take you step by step on this for you to understand and make sure that you are with us. So let's do it. Since I've already displayed that, we can just do it together before we go to any break. Okay. So here is the worked example that is there. Consider the following information. Here we are given that the total number of the sample space is 16, and we are given that the total number that is only on A is 6, and also the one that is on B it's 11, right? So, and also we are given that there is an intersection of both of them where they are is equals to 3. So which simple means that if I have 6 here, then 3 is still here. If I have 11 here, then 3 is also coming out of that. And the last one we are given is that we have the probability, the number, total number of A, or which we said it's a union of B will be equals to 14. Every time I see that, my mind just think of addition rule, right? So the moment you see an or you see a union, think of an addition rule. If you have to jot it down quickly, do that, because the question will come with that question at any point. Okay, that's one of the tips. So now they say represent this in a Venn diagram. So let's do it together. The way we did our Venn diagram there, let me just quickly put my sample space. I always start with the sample space because it is easy to forget it, especially when you are writing examination and you just rush and then you draw only the circles. You forget that this is a sample space. You have to show that it is inside some sort of a sample space. So please try to do that. It might work because it does work for me when I'm starting like that. So that's first tip. Start by your sample space, draw your intersection properly, and then the second tip will be make sure that you start by putting things that you are given, right? So let's start. They told us that the total number of the sample space is 16. So now we know that is what we are looking for. And they told us that the total number of the A is equals to 6, right? Also, they told us that the total number of B events, it's actually 11. That is what we have and what we know. But they went on and they gave us something more. They said that there is an intersection between A and B, which is 3. So I'm just going to put my 3 there. And then they said, with all this, I will pause, because I start with intersection before I can go to the side way. Why? So that I can subtract whatever it is that is been taken already by the intersection, because we cannot repeat it. We have to make sure that we stay like that. Okay, so let's see. Here I am going to have 6, which is the total that I'm given, and I subtract 3. Where's the 3 coming from? The one that is on the intersection. Please remember that. It's very, very important for us to subtract the intersection. Okay, so when you do that, you're going to find your answer then to be 3. You see, then you do the same on the B. It's 11 minus the intersection, which is 3. And that will be equals to the total that we have, which is 8. But if I calculate this and I say, okay, I have 3 and I have 8. The total of them, I have 3, I have 3, I have 8. The total of this is not giving me 16. Something is missing. So what is missing then? We can find it by doing some sort of calculations, or you can actually just say 3 plus 3 is 6, plus 8 is 14. What is missing for me to have the total of 16 will then be 2. Or you can literally write it down and say, okay, my full probability is 16. So you can say my full sample is 16, right? I know that. So my full sample must give me the whole of sample of A, not probability, the whole of sample of A, right? And also the whole of sample of B. So if I add this together, I must get the 16. But if I don't, then this means there's something on the space. Remember, we say this is a sample space. So there's something on the space. So let's see if that gives us. We already know this is 16. And if I come this side, I have my 6, right? My 3, which is that one of A. And then I have my 8, which is that one of B, plus the 3 that I have in between, right? If I add this thing together, will I get the 16? And if not, something is missing. So as we said, this is giving us 14. So which means there's something on the space which is missing. Then that's where we come and then we add the 2 for it to be 16. So that we know that outside here we do have the 2. Or you can use any mathematical way to get to that. Okay. That is done. We have responded to that. We have drawn our Venn diagram with all the information that are needed, and we have managed to understand what it is that we have and what it means. Now, the second question, they said, determine the probability now of a intersection of B, right? Which is AND. Remember, you must now find the probability of the middle part. But that is not just the numbers, it's the probability. So the probability is always written as a fraction, or it has to be 1, or it can be a decimal. So in this case, we have 3, which is in the intersection, but the total of it is now 16. So that's why we're going to say the probability of A intersecting B is 3 divided by 16. Just like that. And that's how you get to the answer. Right. Now, number C, they said calculate the probability of A union B, right? Which means or. So that is A or B. Please make sure that your intersection doesn't look like Teacher Tandy's one that looks like NA. It has to be the correct one, because if it's not, then they will think you have something else. So whenever we're looking for that, we're going to go back to our additional rule. If you remember, when I was highlighting this one, I did tell you that we might need to remember our addition rule, which is the probability of A plus the probability of B minus the probability of A intersecting B, right? So that is the formula that we have. So let's fill it in. What is the probability of A? The probability of A that we already have will be equals to 11 divided by 16. And what is the probability of B? The probability of B is going to be, the probability of B, I'm trying to figure out why did I say, oh, the probability of A is 11. That doesn't make sense. Probability of A can be 11 because that is the B. Let's fix it. That's supposed to be the one for B. Okay, so the probability of A according to the information given is what we have as 6 divided by 16, and the probability of B is 11 divided by 16. Right, that is the correct one. And then we subtract by the union, which is 3 divided by 16, by the intersection, which is 3 divided by 16. If you add this together, they should be able to give us to the solution, or you can use your calculator. This is how we are going to do that. And if I use my calculator there, I can be able to find that that will give me 14 divided by 16, which if I divide further or simplify further, that will be 7 divided by 8. So that means that the probability of O is actually 7 divided by 8, right? It looks like a lot, but it is doable, and I do believe that you guys can be able to do that. We are about to do that thing that we always like to do together. Let's work together now. So as I leave you to do it together with me, I'm going to just leave you with that slide. That is taken from the 2018 question paper, which is national. I want us to go through it together. See you right after the break. Are we ready to go together? Let's see. There we are. Let's analyze this together. Remember, grade 10s, you cannot be the best person if you're the best maths person if you don't do it yourself. Don't always rely on us. You need to always try and write by yourself, and you get it wrong and you keep on practicing until you get it right. That is how it works in this math space. Okay, so let's do this question. It's from question paper 2018 that you already can find it in the DBE website and in any other spaces that has the question paper. So that they said in a random physical science experiment, A and B are two different events. It was found that, so there were two events that they have done, two experiments in the physical science class, but then they found that the probability of A is equals to 2 divided by 5, and the probability of not B. Please just pay attention to that, because this means it is not, right? So when I see this, initially, before I even look at the questions, I'll start wondering, then what is B? What must you do? Quickly calculate what B can be, right? Using your complementary rule. So that is what you have to put in mind. I even look at the question, I'm just analyzing, and I do what I can. Now the third one we are given is the probability of A union B, which is A or B. Remember I said the moment you see this, what must you think of? Addition rule. Yes. So when I have this two, I'm already have two things that I know. I have to find my B, and somehow the addition rule must come in for the fact that they have given me an O. Okay, so you not always look for numbers or event that is actually happening. They can give you the result, you work backward. Just bear in mind. Okay, so the question says, calculate. You see, there we are. They now want you to calculate the probability of B. So what did we say? We say the probability of not B, it's always equals to 1 minus the probability of B. That is how the complementary formula is written, right? So let's write it that way. So that means for number A, we already have the way to go. So now here we're going to put 3 divided by 8 equals 1 minus the probability of B, which is what we are looking for, right? So I need to try and have the probability of B by itself. For me to do that, I need to remove everything away from it. First of all, I'm going to subtract the 1. So when I do it on the right, I have to do on the left. So I'm going to say minus 1 in both sides. So it's going to be written like this. 3 divided by 8 minus 1 equals 1 minus 1 minus the probability of B. So that is what we are trying to put down. So for me to have that properly, that's how I'm going to do it. Okay. Then you can quickly just use your calculator to find what will that be. But already on my right hand side, I know that I have a negative probability of B. Right? I don't want that negative. I want it to go somewhere. So it actually must go this side. So but before that, you can actually just quickly take your calculator and get to what you have there. We have 3 divided by 8, which is, and when we minus 1, we get the answer as a negative 5 divided by 8. Right? When I have that, remember I only want the probability, not with a minus. So I'm going to multiply both sides by a negative 1 so that I can get rid of this. You can either multiply or you can divide, but then you will divide by what? A negative 1. So just choose whichever works for you, because a negative divided by a negative is a positive. A negative multiplied by a negative is a positive. So at the end of the day, the probability of B will then be equal to a positive 5 divided by 8. Okay. So that's 1. We have found that. So we can just come write it here so that we don't forget. The probability of B equals to 5 divided by 8. And we leave it. Okay. Now, the second question, we are now asked to find the probability of A when it's intersecting with B. Right? For me to get that, I would need more information. I need the probability of A. I need the probability of B. I need the probability of the union of the two. So that means I need my addition rule. So I'm going to go there and I write probability of A, or as they gave us, B. It's equals to, remember this is my formula, probability of A plus probability of B minus the probability of A and B. Right? Now I will start right away to substitute what I have and remain with what I don't have. So I do have the probability of A or B. It's given as 5 divided by 7. Okay? I have the probability of A. I was given as 2 divided by 5. I just have calculated the probability of B, which I said is 5 divided by 8. What I don't have is just the probability of the intersection. So I'm going to leave that. Easy, right? Because as soon as I have that, it then shows what I'm looking for. Then you can quickly just use your calculator, do what you have to do to get to the answer. So let's see. There, if I use my calculator from the other side, so I have 5 divided by 7 equals 2. Let's quickly do that together. So we have 2 divided by 5 plus 5 divided by 8. And that gives us 41 divided by 40. Right? And then we still have our probability of A and B. So we can just quickly work around that, and then we can get the probability of A and B by itself. So we need to move this 2 to the other side, then we can remain with only the probability of A and B, or we can literally just move the whole of this part to the left, and then we move this part to the right. But remember, the way we move them, we have to literally just use the opposite side of what it is. For example, with 5 divided by 7, we would have to say minus 5 divided by 7 in both sides of our equation, so that the minus 5 divided by 7 will then be on our right hand side. So that is what we are doing. And then the negative will then go to the other side, but for it to go to the other side, we would have to say negative the probability of A and B plus, and that must happen on the both sides, plus the same thing. So that's why we're going to land with the probability of that and B, right, like that. And then we work that out until we get to the answer. So that is the probability which we have, and that is what we're going to solve right now. So let's say we have 41 divided by 40, and then we are subtracting how much? 5 divided by 7, and that gives us something like 87 divided by 200 and something, or we can literally write it as a decimal, which is 0.31. Remember, I did tell you that we can use decimals as well, right? Then they come and say, hence, determine whether the event A and B are mutual exclusive and motivate your answer. What did we say it must happen for mutual exclusive? For any mutual exclusive, the event of A and B must always be equals to 0. So if this is not equals to 0, then it's not mutually exclusive. So that's what you do. You have already proven that the probability of A and B is not 0. So which means this is not mutual exclusive. And that's how you're going to answer the last question. Just going to show you how this is then marked, if we have to mark it in the examination spot, where you can see that as long as you put your formula together in grade 10, we do give you marks for those formulas that you are able to identify and calculate properly. Right? So that is what is happening there, and that is how you're going to get to the answer. So let's quickly just look at this one, because it's more of what we also need to know and how to do. Remember, we are doing it together. It's not one man's work, it's all of us, so that we can learn. The Venn diagram below represents different scenarios of the event. So write down the probability of the shaded region for each. So they just want us to write the probability of what is shaded, right? So if you look at this one, here the probability will be the intersection. So that means we have the probability of A and the intersection, and then we have our B. That's how you're going to write that. You can write it in this format, or you can use the word and then you don't put the intersection. Okay. Then the second one, you can see that is the probability, supposed to be the probability of A and, or not and, this one is an or one, supposed to be that, but it's not. Right. So every time you don't have intersection, and also when you don't have, so you just have to say it is the probability that it's not that, the probability that is something else. So this does not have any intersection. If you look at it together, just show that they are joined a little bit, but doesn't have the shaded space that you would have said that it's a probability of the intersection. So it doesn't have the intersection there, so you cannot put the intersection in that point, right? The third one is the probability. Also, you can see that the shaded part does not include the intersection there. So it does show that this is not the intersection. So you can write it as like that, and then you just put it's not like that. Okay. And then they say which diagram in these questions represent mutual exclusive. The one that does not have the intersection is the one that is mutual exclusive, and that will leave us with the third one, because it does not have mutual exclusive. There's no any intersection into that one at all, right? I'm sure that you guys have seen that, and you can be able to then go and do more questions with that. We do have many questions that we would like you guys to do. And as we stay with this few minutes that we have, I am just going to show you that question, and so that you know what you need to deal with and how you have to deal with it in the examination position. So this one you can quickly get. So I'm just going to move again for you to just take a screenshot of the next one. So if we don't get to it, you and Maski will have to get to it together. Because remember, Musky can help you to answer the questions that we are not able to support you now in Musky TV. You just have to simply save the numbers and communicate with Musky on WhatsApp. What do you say? Hi, and Musky will give you everything that you want. Ask any question, text, screenshot, voice note. The number is 072-091-0388. Take a screenshot and wait for me to finish the other one. See you right now. Let's do this one together as I have promised, and where we are not able, you can then go find the question paper. Is a question paper that was 2017 final examination that you can find it online if you need to, and if we can't get to it right since we don't have much time. But let's quickly do this together and then we are able to see what needs to be done. Two events A and B are complementary. They're actually telling us that they are complementary, and when they say that, I always just close my eyes and think of the formula of it not be, right? The one that says that if it's complementary, then it means that the probability must be equals to 1, and that is what is important. And they say then, and make up the entire sample space, and also we have that the probability of not being A, it's equals to 0.35. So that is the important part of it. Here they say complete the statement. I mean, I just have said to you, you need to be able to say it on the chart, right? To say what that statement will be completed with. The probability of A plus the probability of B. If ever I'm told that this is a complementary event, it has to be equals to 1. It's a must that is equals to 1. You can't do it otherwise. Okay. Then they say write down the value of probability of A and the probability of B. Now for here, we would have to first find the probability of A and the probability of B. They said it's complementary, and the only thing that we know now is that we have this all sample space. So quickly, you can just write what you have to do, and you can see that the probability of A of B of A will then be what it is not, and which will be the probability of B, right? So that is what we have here. So I'm just gonna quickly, since we don't have time, just gonna quickly show how that was worked out for us to move. So the probability of A and B is going to be not be possible, but the probability of A and B, it's not going to be possible because that's an end statement, and we're only told that it can't happen since we have a complementary statement there, right? And then the last one was for us to then find the probability of where it is B, which is not A, right? So that's what we are looking for. So for you to find the probability of B, you would have to just write the one that is given to us, which is the probability of not A. So suppose that we were given a statement to then find the probability of A, which in this case they did not ask. So they can ask you to find the probability of A. So what you do is just take what you are given and you use the statement of saying the probability of A will be found from the probability of not A, which is 1 minus the probability of A, just like we did on the previous one. And then you substitute your probability of not A, which is 0.35, and then you work out the magic there until you get your probability of A. And that will be the probability of A should be something like, I think, 0.65. We'll check that. So that is 1 minus 0.35. Let's see if I do that quickly, if it will give us what we think it should be. 1 minus 0.35, it is, yes, of course, 0.65. So if that was the question which is not there, if you were supposed to answer the question where you have to find the probability of A, you will just have to calculate it like that. I hope you guys have enjoyed and have got this properly. Unfortunately, we were not able to do the second question, but I believe I need to share this with you before we go so that you have it with you and you can understand. This is taken from our Platinum textbook, page 304. You can see that is summarized nicely. What is probability? What does probability have? And there's nice formulas that we're busy talking about and how it works with the Venn diagram. So this is very important for the mutually exclusive. You can see that the things cannot happen at the same time, and then where there is it is not mutually exclusive, you can see that there's intersection there and all those kind of things. So this is very, very important, and I believe that you guys can use this to get more of what you need. As promised, Mask is always there to help you. I believe we have enjoyed and we can use this going forward to learn probability. And as always, the whole South Africa and the world at large, Mask Miller Learning and Mask TV are always here to help you in educational context. See you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.